Yes. Another water soluble vitamin is pyridoxine. It is called as B6, vitamin B6, pyridoxine. If you see the other names for pyridoxine, this is called as rat anti-dermatitis factor. Rat anti-dermatitis factor, because for the first time it is observed in the rats. So the deficiency of this vitamin is observed in rats. So it was found that this can serve as a anti-dermatitis factor because it prevents the dermatitis. So it is called as anti-dermatitis factor. So it is called as anti-dermatitis factor. If you see the chemistry of pyridoxine, there are three forms of pyridoxine are available: pyridoxine, pyridoxal, pyridoxamine. Pyridoxine, pyridoxal, pyridoxamine. Three forms of vitamin B6 are there: pyridoxine, pyridoxal, pyridoxamine. If you see the sources of this vitamin B6, dried yeast is a good source of this vitamin. Rice polishings, wheat germs, cereals, legumes, oil seeds, egg, milk, meat, fish, green leafy vegetables are the good sources of this vitamin pyridoxine or B6. Even intestinal bacteria can also synthesize this vitamin B6. And if you see the required dietary allowance, it is about 1 to 2 milligrams per day, and pregnancy and lactation it can be increased up to 2.5 milligrams per day. If you see the coenzyme form of this vitamin B6, it is pyridoxal phosphate, PLP. PLP means pyridoxal phosphate is the coenzyme form of this vitamin B6. So pyridoxine is converted to pyridoxal, and pyridoxal is phosphated by donation of phosphate group from ATP and converts results in the formation of pyridoxal phosphate. Okay, pyridoxal phosphate is the coenzyme form or active form of this vitamin B6. If you see the functions, it is involved in wide variety of metabolic reactions in the body, and it is mainly involved in amino acid metabolism. Like if you see transamination reactions, this ALT or SGPT and SGOT, these are called transaminases, and these enzymes are involved in transamination reaction, and these transamination reactions are dependent on pyridoxal phosphate. PLP requires as coenzyme. Now this pyridoxal phosphate is also involved in decarboxylation reactions. If you see many decarboxylation reactions, this requires pyridoxal phosphate as coenzyme. If you see the decarboxylation of glutamate to gamma aminobutyric acid, requires this pyridoxal phosphate as coenzyme. Histidine conversion, decarboxylation to histamine, 5-hydroxy tryptophan to serotonin, cysteine to taurine, serine to ethanolamine, dihydroxy. Conversion of this dopa to dopamine is also requires this pyridoxal phosphate for the decarboxylation reaction. So pyridoxal phosphate is required for many decarboxylation reaction as coenzyme. And non-oxidative deamination of hydroxy amino acids catalyzed by the enzyme dehydratases or deaminases also requires this pyridoxal phosphate as coenzyme. Pyridoxal phosphate as coenzyme. And sulfur containing amino acids like cysteine, cysteine and methionine, if you see the transulfuration reactions, conversion of homocysteine to cystathione, and finally results in the formation of cysteine and homoserine. So these enzymes also require this pyridoxal phosphate as coenzyme, and it is required in desulfhydrases reactions also. Desulfhydrases reactions also, non-oxidative deamination of cysteine to pyruvate amino acid and then to pyruvate also requires this PLP, pyridoxal phosphate as coenzyme. Then interconversion of glycine to serine and serine to glycine by the enzyme serine hydroxy methyl transferase. So there is a transfer of methyl group from tetrahydrofolic acid, and this is converted to N5 and 10 methylene tetrahydrofolate. So methylene group from serine is taken up by the tetrahydrofolate. It gets converted to N5 and 10 methylene tetrahydrofolate, converted to glycine by the enzyme serine hydroxy methyl transferase. This reaction also requires pyridoxal phosphate PLP as coenzyme. And PLP is also required for the synthesis of niacin in tryptophan metabolism. In tryptophan metabolism, if you see 3-hydroxykynurenine is formed as an intermediate, this gets converted to 3-hydroxyanthranilic acid, from which this niacin is synthesized. This kynurenase enzyme requires this pyridoxal phosphate as coenzyme. So PLP deficiency can affect many metabolisms. So PLP deficiency, if you take in this example, deficiency results in the accumulation of 3-hydroxykynurenine, which is converted to a compound called xanthurenic acid and excreted in urine, resulting in a condition called xanthuria. Okay. Then this PLP pyridoxal phosphate is required in heme synthesis also. In the rate limiting step and the first step of heme synthesis is conversion of succinyl CoA plus glycine into delta aminolevulinic acid by the enzyme ALA synthase. This requires PLP. Then carbohydrate metabolism, if you see glycogen degradation means glycogenolysis by mesyl phosphorylase enzyme to form glucose 1-phosphate requires pyridoxal phosphate. So more than 70% of total pyridoxal phosphate content of the body is in muscle, where it is present as enzyme. Now this pyridoxal phosphate is also required in lipid metabolism. The formation of ceramide and sphingolipids requires this pyridoxal phosphate. Intramitochondrial fatty acid synthesis and chain elongation also requires this PLP. Biosynthesis of arachidonic acid from linoleic acid also requires pyridoxal phosphate. Coenzyme A synthesis also requires PLP, means the formation of coenzyme A also requires this pyridoxal phosphate. Now what will happen in case of pyridoxal phosphate deficiency? So this deficiency of pyridoxine or PLP, pyridoxal phosphate, if you see, neurological manifestations are seen. These are due to insufficient production of compounds like serotonin, epinephrine, norepinephrine and GABA, because this tryptophan is the amino acid which is required for the formation of these compounds, serotonin, epinephrine, norepinephrine and gamma aminobutyric acid is also formed as a decarboxylation from the glutamate amino acid. So these compounds are required for the brain development and neurological function. So since this PLP is associated with the production of these compounds, the deficiency of this pyridoxal phosphate will have mainly on neurological manifestations. In infants, if you see, the convulsions also can occur because due to decreased synthesis of inhibitory neurotransmitter GABA. So demyelination and consequent peripheral neuritis, due to decreased synthesis of sphingolipids. Demyelination and consequent peripheral neuritis is also seen due to decreased synthesis of sphingomyelins. And dermatological manifestations, pyridoxal phosphate deficiency affects the amino acid metabolism tryptophan. So what will happen? This results in the defective synthesis of niacin. Niacin deficiency can lead to pellagra. So dermatological manifestations are also seen in case of deficiency of pyridoxal phosphate. Now hematological manifestations, if you see, hypochromic microcytic anemia is seen in case of pyridoxine or pyridoxal phosphate deficiency, because pyridoxal phosphate is involved in heme synthesis as coenzyme for ALA synthase enzyme. So if you see the drugs which can cause pyridoxal phosphate deficiency, isoniazid is an anti-tuberculosis drug. It can inhibit pyridoxal kinase. So as a result, there is a less formation of pyridoxal phosphate. So pyridoxal phosphate deficiency can occur in case of isoniazid. Then cyclosporine, penicillamine or other drugs which can inactivate this pyridoxal phosphate by forming thiazoline derivatives. And ethanol intake, alcohol intake also can cause the pyridoxal phosphate deficiency, because it is converted to acetaldehyde and that inactivates the pyridoxal phosphate. And if you see the diagnosis of pyridoxal phosphate deficiency, urinary examination for 4-pyridoxic acid And tryptophan load test, a load dose of 2 grams of tryptophan is given, and excretion of greater than 3 mg per of xanthurenic acid in next 24 hours indicate PLP deficiency. Now methionine loading test